Okay, so in the name of God, the compassionate, the merciful, this is week 3 of our C++ TMP practice sessions. We didn't make them as planned. We didn't make it to going one theory session and then one practice session as planned. That means that we have piled them up all to the end. So that's why we are going all practice sessions from I think 2 weeks ago. So let's see. So we have already gone through the following examples from, or the following functions from the Haskell list library. We have done null, head, last, bang bang, plus plus, and map. And so last week when I was going through the various, actually three different solutions of mine for map, we made it to the point that I said, well, you know, guys, it's variadics are not exactly C++, sorry, are not exactly the Idris vectors either, for yet another reason. The reason is that there is a heterogeneity in the types of the elements, the n elements that you can put there. So long as the values that you have are literal types, then you're fine, and they don't need to be the exact same literal types, right? Now, in the very end, James, who sadly had to leave this call because of his call, stated rank n types of Haskell as of a possibility for producing heterogeneous vectors or lists in Idris. I had a small research on that, and apparently there is no such thing in Idris as rank n types. Now, if you ever find out that that's wrong, please do correct me. I would be delighted to know that I am wrong. Okay. Now, what else? So I told you at the very end of our last week's session that I have this requirement put in for our list to make sure that even though there is no intrinsic requirement by the C++ template, well, non-value template packs, that they should all come from the same literal type. I would want to enforce that they do, so that this is kind of a loyal translation of the a more loyal translation of the Idris vector. Now I told you that is done using this const eval function is unityped that I have implemented myself. The implementation is actually quite simple. So there are relatively few. There are 4 cases that you have to consider, so that you make them, maybe even less, I don't know, so that you can make sure that a pack is unityped. There's the case of the empty pack. So that's the first overload that you can see here on line 11. By the way, is this readable enough?
Yeah.
Yeah. Okay. Very good. And then there's the case where there's only 1 in there. And there is yet another one. I said 4 because there are 4 lines here, but I miscounted them. This is the third one. So I'm gonna, oops. What I'm gonna do is that I'm gonna put this on a separate line so I don't make this mistake again. So there is another one which is for when there is more than 1 element of the pack. And so the first 2 I would say easy for you to understand. The third one is slightly less familiar, because it has made use of this stood meta function. So if we go to let's see, if we go to TPP reference and search for is the same or is same v, doesn't really change anything. You will see that there's this meta function defined in this header type traits, which takes two types and then type reduces. So it's saying type reduces to either true type or false type. And that's not true and false, right? Those, being a meta function, have a nested data member, nested static data member called value. As I had told you before, this is kind of the convention in the C++ TMP, or it used to be. The human-to-human convention, that if a meta function returns a value, you would put that in a static context per data member of that struct that you call value, right? So because of this, you can acquire that, and there is this alias template that has this extra underline v in it, which is a shorthand for acquiring this colon value of the thing. I have made use of this one, which this being a bool will return, or will type reduce to either true or false, right? Now, how did I use that? Well, if you come to here, what I'm saying is that I want type of X to be the same as the type of X's for every X's in the pack. And I'm performing an AND on the results. Now, this pack expansion magic is something that we have in the past also seen, but I should point you to a page in the I think it's I think it's in chapter 12 that I have already given to you, but if it is not, you know, I should just make a screenshot. It has this very nice table in the book about what different unpacking what different expansion syntaxes will expand to, right? Now this one is saying that you check the same typeness of decal type of X and decal type of X's for every one of them, and you AND the result of, right? So now Mikhail, are you lost with this?
No, I think I understand it. It's just
okay.
Weird syntax.
Yes, it's a very weird syntax. That for sure is the case. But I mean, you know, I have in the past expressed my my condolences for the various syntactic choices in C++. I don't think that this is one that I would spare my condolences for, because if you see the full picture, which is the cases where they wanted to cover, this is not a terribly bad choice. You know, it's so I shall dig that table out for you, and then I think that will give you a better chance of having the full picture. Niels, are you following?
Yeah.
Okay, Jan. Very good. So once we have that, we can ensure using a requires clause that these guys are all of the same type. Okay. So that's the leftover from the previous session. Do we have any questions from the functions that we have thus far covered? No? Okay. I think this is a good time for a joke. I'm going to start with Niels.
Me?
Yes.
See if I have prepared some jokes here.
Okay.
What do you play when you have nothing else to do?
Well, I play Reversey.
Play.
What do you do?
Board games.
Board games. Yes, sure. Sure. Right. That's yes, of course. Very, very good naming. Very good naming. Yes. Yes. Okay. Excellent. Thank you. Right. Now that we have played our board games, let's go to some business. So let me see what's next. Oh, we never did take, right? So
No, we
take
finished with
is,
map.
okay. So the syntax of take is such that it takes a list and a well, which way is it? Let me just double check here. Where's my okay. It wants oh, here it is. Right, so it takes a natural number and then a list or a vect, then it takes then it returns the first n elements of that vector. Now maybe I should put up the implementation of that. That's anyway going to be very instructive. I'm sorry. So here's the address implementation. In case you find that useful. Now you have 4 minutes to get this done. And that started just now. Okay. Okay, 2 minutes passed. I forgot to bring my page bill with me to Istanbul. So I'm only going to tell you the time's up. I'm not going to page you.
Just have to keep track of it ourselves.
Yeah. Oh, I know what to do. I have an alternative. 1 minute left. Yeah, that wasn't really good. That was my ring. And it didn't work quite well. Okay, time's up. Who's done? No. Oh, really? Okay, so fine. Then we can have another minute. And I am going to open the window. I'm not sure how, I mean, I'm on a busy road. So if you hear a lot of noise and my noise cancellation doesn't work properly, just let me know. Yeah.
Yeah.
Was that you being done with it, Jan?
No, I was commenting on that I couldn't hear you.
Oh, okay. So you can't,
That's
you can't,
okay.
you
No,
can't hear
just for
the
a
street
second there.
noise.
Now I can. Now I can.
Okay.
It was
Okay.
just you said you opened the window and then you went into the other sound dimension.
Okay. Okay. So can you hear the street noise?
No,
Okay. Very good.
Zoom is filtering it out efficiently.
Very good. Very good. You have already had 2 more minutes, and I'm getting a bit disappointed.
I forget how I raise an error when it. Wait.
Ah, I
No,
see.
I'm not going. I'm not supposed to
Yeah.
raise an error. Never mind.
Yeah, no.
I forgot how take works.
You forgot how take works. Well, that's already on the screen.
Yeah.
I
But like in my head, it was like when you try to take more, it's supposed to be an error, but no, you just
No, it
take the
doesn't.
entire list.
Yeah.
Yeah.
Take is greedy.
So I think I'm done. I haven't tested.
okay. Well, I think so what you just said, Niels, is the Haskell understanding of take. But that's fine. Let's see. I mean, we are in the world of dependent typing, which is richer, so we can perform richer actions on it, but that's fine. Let's see your solution.
Okay, can't share screen.
I mean, wait. Is anyone else done?
I think so. I have one check that I haven't done properly, but yeah.
Okay, then given that Niels has already given his joke, then I would ask for Jan to, please.
And I will shame myself. Yes.
Yes.
Is this good?
Let me just stop sharing.
Share screen. I would like to share desktop. Main sysuper Doom Emacs. I'm sharing main sysuper Doom Emacs now.
Yes.
There we go.
Okay. Where is your take? Okay.
Take is the bottom one here. I can do this. Okay, that was not helpful. This might be helpful. Right. Here. Thing is, I don't know how to check for. I guess I'm wondering if I should check for when n is 0 in the split case, or if there's a way of doing it more cleverly in like the template.
Probably you would want to move that n. Well, you are already doing that. Sorry. But you should be able to do that. My apologies. You should be able to do that because well,
so just in here.
Fine. Let's see. Let's see. Before we're going into that, could you please just walk us through the logic of your implementation?
Sure. If it's okay, wait. I am not done actually. Let's see. No, I am. So,
well, that's just the type. You want an instance of that type, so you would need to have a not that. Yeah, you would need a pair of round parentheses after the angle brackets. Or if you want to return L, that is also fine because your list is your L is also empty, right? So that's the logic is correct either way you want, right?
So yeah. So prepend. Let's take the interesting case first. Where you prepend X, meaning the first element to the recursive 12 take with a decremented n. And the second one, you should once the n is gone or the list is empty, it should be just return nil. So greedy.
Well, yeah. How do you check that your n is 0 in this case?
I don't. That's what I was wondering. So
okay, that's fine. That's fine. Now Niels,
I remember us doing this. Yeah,
that's fine. We'll work through it. Thank you very much. Niels, do you have a better solution?
I don't know if I have a better solution.
Okay.
But this is my solution. I can run it, see if it works.
No, you.
Oh, I didn't print it. It doesn't look like it's working, you know. There.
Okay, just the if that works too.
I mean,
and remember there was a better way of doing this.
Why is it?
I think what you want to do is an instance of L2, not the type. You want to right, is it? Oh, that's an instance itself. Right. Okay. Do you have a have you worked out a printouts function for lists?
No, but previously.
It doesn't matter. It doesn't really matter. Okay. Now let's.
It doesn't look like it's working anyway.
Fine. Let's see your logic. So on line 31, what do you do there?
Wait, what am I doing?
No, on line 31.
If it's an empty list, I just return it.
Okay, regardless of what size you're
Yeah,
after. So-
because it's an empty list. It will not get bigger.
okay.
If
Hmm.
this is wrong, it's supposed to be this. There we go.
Okay.
And now it is not
Okay.
not working.
Well, probably because you want it, you should be performing that check that n equals 0 at compile time.
Yes.
So that's if const expert. Okay, that's better.
And now it's
Okay.
it's not a non.
Aha. So you see, you are taking the n parameter at runtime. It's a value level parameter. It's not a type level parameter. It's not a template parameter. That's it.
Yeah. Okay, yeah. That's
Okay.
why.
Okay. Now, how do you go by solving that problem?
And then instead of passing it here, no, because
Well,
now it wants.
and why is it that you put x's first and then x on line 33?
Let's take one.
Right.
Because and here I do this. Because I remember where you said you wanted it in the same order. When we did
Sure, but now the one that I told you about was the ordering of x and sorry, the list and the bang other operators.
Yeah.
Not about x and x's. So what you're saying is that on
Oh.
line 34, there is first x and then x's, which is the meaningful thing to do. But on line 33, there is x's and then there is x. So they're in reverse order.
I didn't think about the order in
That's fine.
on them.
That's fine. Now,
No.
where do you think things are going wrong?
Here, let's see. I'm guessing since it's missing a case of being just
That's
one.
true.
Yeah.
That's true. Now, where do you think the case that it's missing is?
In like the template, there's no X. So like.
Is that what it is missing? Is that what it is missing?
No.
Take a look at it.
Hmm.
Take a look at your error message, please.
Yeah. No matching function called to take in instance of the function.
No, get it the full error message.
I just let's see here. No instantiation of const vector auto take with.
Yeah. So we have this very huge n.
From.
Let me move this to the bottom. Okay, so x is 3. Right. X is okay. You have really screwed the list of parameters. Just go further up in the code.
Yeah.
Let's see.
Like, do you want to for take, or do you want to see?
That's where I want it to be. That's right. Yes. Okay. Now I'm gonna give you a small hint. and then I will show you my solution and we'll discuss it in there. Now, so you see on line 31, you have another overload, which itself is not templatized.
Yes.
Which is very sensible because you don't need a template parameter for an empty list. Okay. Now, then you
I'm
one
still
after
taking
the
an
other.
argument, but
Okay, you're getting there. No,
Yeah.
no, it's not that. No.
Shouldn't that be
You should remove that. You should
yeah.
remove that. Yeah.
Because it's not
Okay.
but it should still be a template, even though I'm ignoring it.
So that's the thing. I think
Yeah.
your error message is unhappy with, because on line 40, when you do the recursive calls,
Yeah.
you are absolutely at that position going to take within the angle brackets 0, take my head to be the 0, right, of the list, right? Now that means that you explicitly are instructing the compiler to make a call to the template version. Okay, so that's where you get stuck. Now don't worry, don't try to fix that right now.
Okay.
I'll just share my version. So we want this, and this, the 3 canonical pages that I always show you. Now, I would like to start by drawing your attention to the fact that in the Idris one, you take the first elements of a vector of size n plus m.
It forces
So
you
right at the type level, you're enforcing that the vector should have more elements than we are going to acquire. Okay, and provided that that is the case, then you return a vector of size n. Then at the value level, there are the cases that you guys were all going through. Okay, now let's see my solution that is trying to simulate this, and we'll see what the different trade-offs are. So right. Okay. So my solution is just one overload, right? And then what it does is that it performs a k-split inside the body of that one overload. There is the case of where n is 0, for which it returns an empty list, right? So we are done with our search through the list. We have already picked enough of it. There is nothing else that we are interested in. We'll just return the empty list, right? Or, well, given that we have already, oh, this is not exactly correct. Oh yes, it is. It is in a more clever way. Given that we have this required, clause, requires clause. Now we have already checked that n is non-zero, and we have already checked that n is less than or equal to the size of x's. Therefore, there is at least one element in the x's. Therefore, we can safely acquire the head of it and prepend that to the take of the n-1 of the tail of the list that we're given. Is everyone following? Okay, very good. Now, I have never asked you to put these things in because I had never taught you those before the practice sessions, right? But you are expected in the C++ TMP assignments that you hand in, you are expected to put them in because we are gradually developing the skills, right? So be aware.
That was the one I was thinking about, and
Absolutely,
because,
absolutely,
yeah,
absolutely.
but I forgot how to do it since it's early, so
that's okay. We are, like I said, we will gradually develop the skill, right? It's absolutely fine. These are only the practice sessions. It's correct. I time you, and try to discipline the timing so that you guys force yourself for the implementation in a timely fashion. But that's only for you guys to to push it through. It doesn't mean that you have to be perfect, right? And it doesn't mean so in the C++ solutions that you're going to hand in, but I'm just trying to educate them. Anyway, so now I think you already know the answer to this one. So the question is, and I'm going to ask that question from Mikhail. Now, why not should we, instead of just one overload, let's see. Right, why did I perform the if const expr instead of doing this? Why did I not specialize the take function for 0? Well, this is not quite syntax. Let me just
Well, that's a funny thing because that's how I did it in my implementation. So now
Okay,
I'm wondering
okay,
what I did wrong.
Interesting. So you couldn't figure out what was going wrong.
Well,
Well,
I can't figure out because I'm on a new laptop today, so I don't have the list class and I don't have the prepend function. So those are red.
Okay. Well, anyone has any idea?
I'm thinking you're mixing value like runtime and compile time values again.
No,
Okay.
this is
Both are
this
compile
is
time.
this is me passing 0 as a non-type template parameter. It's within the angle brackets. It's not within the round ones.
Right. So it is a
right
type level. Yeah. Okay.
It's a template parameter. Let's put it this way. I myself go sloppy from time to time on these things, but this is not entirely type level. This is template parameter. This is just a non-type template parameter.
That template. Okay.
Which is compile time, by the way, which has to be compiled.
No, yeah.
Yeah. Niels, do you have any suggestions?
On why?
Yeah. Why did I want to do the if on line 206 instead of giving it another overload as I guess you or all of you have done, which would have been with the signature that is on line 211 and it's common.
less lines to write?
No. Well,
Because now you only have to write an if it's 0 instead of having to write template.
No, it's not that.
Okay.
No, it's not that. So less keystrokes. No, it's not that. No. The reason is this: there are no partial specializations for function templates. Right. So if I wanted to do this, I would have received an error message telling me somehow the various C++ implementations have their own specific ways of doing that. They would report that there are no template specializations for function templates. Now that's different from overloads. You know, the case that you had, for example, Niels, didn't have a template parameter. And we realized that that's not going to give us what we want, right? Which means that if we really wanted to have a another overload, which works with n0, which works for n equals to 0, but within the angle brackets, right? It would have been a specialization, which we don't have for function templates. That's the reason. Okay. Mikhail, are you following?
Yeah, I think so.
You think so? Okay, well,
Yeah.
So what makes you doubtful about you following?
I'm sure it's just a lot going through the head right now.
Okay. Now, in order to ease that, would you mind giving us your joke, please?
My joke. Sure. Why couldn't the sailor learn the alphabet?
I didn't know that he couldn't. Okay.
Go on.
I don't know.
Because he only knew the sea?
He always got lost at sea.
Oh!
Right. Very good one. Very good one. Yeah. You guys typically find good jokes. Yeah. Okay. Thank you very much. Now let's see. So, are we done with take? Yeah. Very good. Now then, let's go to. Okay, the next one is filter. Oh, let me see. Sorry, I think there is something in. Right. Oh, so there's no text. Oh, that's interesting. Okay. Right. I just wanted to tell you something about the supremacy of the dependent typing type system of Idris at this point. You know, here is one thing that in C++ TMP we have never really enforced, and that's the matter of the return types, right? If you take a look at line 94 of the Idris type signature, you will realize that it is telling us that the vector that we will receive is of exactly m elements, right? Now, we can, by some sort of verification, for example, make sure that our result here is also of the type n, and sorry, of length n, and we can very much also, instead of making this auto, right, put list of n, sorry, of Right. No. I'm sorry. I take that one back because that takes more education. Right. We can verify it that the list that we return is of the right type, but if we make a mistake, the compiler will not be able to help us, which means that it's not that just we have put this auto here in that we have deliberately given us our ourselves from having to be specific on the return type. We have actually given up compiler support for possible mistakes. So our type theory, as we have put it in, for example, on line 203 to 204, is ignorant of the return type, but quite right with the types that come before the return type. So in comparison to the Idris version, we have lines 92 and 93, but not line 94 in the C++ TMP. Now, here is something relatively complicated. Now, you see this requires clause. This requires clause comes after we are done with these, and it only helps in the overload resolution, which means that the types, the type arguments are now deduced, and the compiler wants to see whether there is any further requirement that it has to fulfill, and if it can't, then that overload is off, right? Which means that at the point that we make it to this requires clause, this auto has to be resolved, which means that we can't enforce anything in the requires clause regarding the return types. Which means that in the C++ world, in the C++ TMP, we can't enforce the return type to have the exact same type as the Idris does. Okay, now there is a way that you can do that, but if you really want to do that, then you have to go to a different level of vectors, in which vectors explicitly carry around their length. Now, our dealing with lists here in C++ TMP, which I have repeatedly told you, are neither the Haskell lists, nor the Idris lists, nor the Idris vectors. Is something between the two latter, right? Is that we take a pack, that pack itself knows its length, right? But we don't explicitly carry around that piece of information so that we can enforce things, for example, like the one that Idris is enforcing on its line 94, here on our line 204. Right? Now we can, if we wanted to, work with another sort of list, which explicitly does carry around its length. But the thing is that I am now teaching you C++ template metaprogramming, and I want you to learn the way that is done. I don't want to explicitly, simulate everything that is in other languages. That's not the point. The point is for you to get to learn C++ TMP as it is practiced. Now, there might be hardcore people that really vigilantly want to show off the power of C++ TMP by doing that, but that's not the point of this course. Okay. Now, having said that, let's go to filter. So, and I'm gonna show you the filter. Ah, this one gets very interesting. This is an occasion when the filter implementation of Idris is not exactly what we need. And here is the reason. You know, having said the entire story about the Idris vectors carrying around the lengths explicitly, if you want to perform a filter, right, because you don't know in advance what the size of the the resulting vector that you get would be, what Idris does is that it works with these dependent pairs, the D pairs, right, that have a constructive evidence for the length of the resulting the resulting vector, right? Now that means that it can't say in advance what the result is going to be, what length the result is going to be of, but it promises it promises instead that it will give you an evidence for you to check whether the resulting vector that you get is of the right length. Right? Now, we are not going to do that in C++ TMP. Right? Would have we wanted to work with vectors in C++ TMP that explicitly also carry their size around, then this would have been one possible take or one possible bit, but we're not doing that now. Let's pretend for a moment that we want to close our eyes to this and go to the Haskell equivalent. So what I'm expecting you to do then is something of this type. Just a moment. T of filter. Okay, it's rather well, not exactly, but it's kind of this one. Right. Now you have 4 minutes. For those of you who are having trouble with passing the function or the predicate, I have now gone to our implementation of map for reference. Now, the time is up, but I have the impression that you're not still done. So I'm going to give you 2 more minutes.
Thank you.
You done, Jan?
No, I thanked you for
Oh,
2 minutes.
you're welcome. Okay, who's done? No one. Come on, boys. Don't be that disappointed. You guys are good. Show me that.
Well, I'm not sure because I don't have the implementation for list or prepend or append or anything. So I'm just assuming that's
Okay,
correct.
right. Okay. Yeah. Yeah, well, you're excused on that one.
I don't work well under pressure.
Okay. Should we stop the
No.
Okay, you guys seem to need more. Okay, well, I'm gonna give you 2 more minutes. And in the meantime, I'm going to play you some music.
Ooh.
Why don't I miss why do I miss the note here? Ah, Okay, time's up. That was me trying to do some the last of the Mohicans. Yeah. Oh, you recognized it. Okay, I'm pleased. That means that I didn't do a very bad job.
No, that was pretty good, pretty good.
Oh, okay.
Let's see.
Okay, good. Now, I don't think that it's wise of us to spend more time on you guys trying to figure it out on your own. It probably is a good idea that I ask you to show me where you stop. So, well, Mikhail seems to be the easiest target because he doesn't have any defense line. So, so we're gonna I'm gonna ask him to first show us his solution.
Okay.
Go on.
It's this. Okay.
Oh, I have to stop my share. Okay.
Oh, there we go. Well, yeah. So this is for when the list is empty. And this is I haven't tested it because I can't.
Sure, I understand. Now, something immediate, you haven't tested it, of course, but something immediate is why did you need to on line 26, why did you need to perform a runtime if statement? Well, if a runtime condition. Okay, that's better. That's one thing. The other is well, on line 19.
19, yeah.
Do you see that red squiggly under your list thing?
Yeah.
Do you understand the comment? No, it's not that. No, it's not that. No. Do you understand the error message that you get?
No template named list. I'm not sure. Do I want it to be?
No, like... no. It's not that. No, it's not.
No, then I don't understand it.
Well, take that part which starts with the L of list until the end of no, not that one, not that one.
Line.
The red on line 19.
Yeah.
The capital L that starts your list.
Mm-hmm.
And the closing round parentheses. Yes, that bit. Can you tell me what this is?
It's an instance of a list.
It's an instance of an empty list. You don't want to instantiate it, right?
Okay.
You want something of that type. Now, well, yes, it is telling you that you don't have a type called list. Probably you don't.
Yeah, I just started this.
Well, that's fine. That's fine. So let's disregard that part of it. Now, let's go into the second overload, which starts on line 23. Mm-hmm. Right. Now, what happens if the compiler wants to perform an overload resolution with empty lists? Will it have a clear choice between the two overloads?
No, so I should probably add something like requires a.
That's one choice, yes, absolutely. And what you do is that you require the size of right, okay. within parentheses. So you would put that x's within parentheses, within round parentheses.
Like this?
Yes. Very good. Okay. So that's another thing. Now, so what? Now a bit of a nitpick. On line 27, your
Okay.
if statement starts. Your if branch, your then branch starts with an opening curly brace, but you only have one statement. It's only a return statement that you have on line 28.
Yeah.
Okay. Now, a lot of that is code that you don't still have. So you don't have a prepend, you don't have a tail, you don't have a filter. Well, you have a filter, right? Now, in prepend, right? In prepend, you put what you want to prepend in a pair of broken angle brackets, right?
Oh yeah, right. So
but that's fine. You didn't have it. You were not told about it. Okay. So what you're doing, you're saying that if f of head of L is true, then you want to prepend x to the filter of f for the rest of, well. Now let's focus on that line 28 and let's focus on the part where you recursively call your filter. You don't have a compiler, but you should be able to tell me whether, that bit is correct. Okay. Very good. That's much better.
Okay.
Okay. What about line 30?
Same thing.
Yes, true.
Oh.
Okay. Fine. Now, did you need to instantiate another list of well, size x's or with x's and pass that, or did you already have an L on line 24? So on line 30, no, not that one.
Yeah.
Not that one. On line 30, you instantiate a new one. Okay, that's even better. Right? Now, fine. Now let's take this to be your ultimate solution, because you can't compile things. I can go through further things here, but fair. You know, that's fair enough. We should take this to be as good as you can make it for now.
Okay, thank you.
Now, thank you very much. Now, Jan, would you mind showing us your solution, please?
Sure thing. Let's see. Share screen. Here we are at my solution. It's at the bottom of your screen currently. If I can navigate to it, please. And now it's not. There it is. Oh, it's at the top. So let's see. Pretty much the same as
Now you have added the requires.
Yeah, no, I had the requires once you showed me the map, because I forgot.
Right.
I didn't have that on my map, which is over here. Here, so, yeah.
Now let's see. Sorry, but one thing.
Go on.
I think you have the wrong.
Oh, I have the thing wrong. The wrong
C++.
way.
Well, that's another thing. But on line 78, I see that you have a red flag for requires, which suggests I was right. So your version of C++ is wrong.
The make file is correct, and I can make this.
Let's say that's C++ 23 that you're after.
Oh, we could put 23 here.
Three.
Yeah.
Okay.
My make doesn't complain, so
okay.
It makes.
Very good.
It's
so
just
your
the linter that's complaining all the time, constantly.
Right. So your editor is not in sync with that.
Yeah.
Okay.
It doesn't like me.
Okay.
I
fine.
don't know how to fix it right.
That's okay. You can enjoy that offline.
Yes.
Now,
and this
is the order right?
The order is wrong again. I thought I had the order right.
Okay.
Can I? Oh God, C++. Brackets. God, is this the right brackets?
I think.
No, it's not.
I think.
There it is. Yeah, and I think these don't have to be bracketed. Yeah.
Yeah, that looks good.
And
Now you have one extra semicolon at the end of the line.
I don't need this.
No, you don't need that. That's only for so you well, when you have a struct, this is legacy from C. Structs need to have a semicolon at the end of them, but I hadn't noticed it that in the previous cases you also had a an extraneous semicolon at the end of your functions. That's not required. No, you're in effect you're creating a an empty statement that is discarded, right? Most likely the optimizer will just throw it away, but just for you to know enough C++. Now, so you have this extra line 78, which checks the invocability. That's excellent, and your copy paste is relatively good. It's so you
I retyped this.
What was it? Sorry,
I retyped this.
Oh, you typed it. My apologies, but I wasn't saying that you are good at copy pasting. I'm just saying that your act of copying what was there is good.
Oh, yeah.
Okay,
Yeah,
my apologies if my comment was too harsh.
No.
Right. Now let's see. F of head of axes, right. But you have missed one thing that I told Mikhail about. Will the compiler be able to figure out the which overload to choose when there is an empty list being sent to filter?
No.
No, it won't, because the pack axes can also be empty.
Yes.
So what you want is to add. This is one way to do it. What you want is to add a requires clause, which makes sure that the pack is non-empty on line 78.
Was that? Let's see. Let me just check how it was written. Where's my and? It was just and then a different one, right?
What was it? Sorry.
And like
yes,
if I want,
yeah. Thus far, this is correct.
Yeah.
Your condition is not right.
Right, wrong way. There we
go. Okay. Now, on line 77, in the list of your arguments, do you spot any mistakes? The parameter is not the argument. 77, yes.
I shouldn't be using auto.
No.
This is very attic.
Hint, 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 hint. It's on your first parameter, not your second.
Oh, geez. Yes.
Okay, that's better.
This can still be, yeah.
Okay. Now you have acquired the head of the pack at various points, and also the tail of the pack. Whereas what you really wanted to acquire the head of and the tail of would have been the head and the tail of the list.
That's fair.
Right? So
No.
can you show me one instance where you have mistakenly called head and correct it, please?
If const is head, then yeah.
Come on, boy.
This probably here.
Why do you say probably?
Probably.
I just said it. I just said it. You want the head of the list, not the head of the pack.
Both of these are the head of the pack. So should I do the head of the list?
Yes.
Yes, all of them are head of the list. The pack, yeah.
No, well, this is not Haskell, so
Yeah, exactly. I have a bad. I've been only thinking Haskell lately, so all of these should be L.
Thinking of better
Much
times.
good.
Yeah.
What was it? Sorry.
He said he was only thinking about Haskell, so I said he was thinking of better times.
Uh-huh. Right. Okay. Okay. Thank you very much.
Good. Good.
Right. I am now going to show you my version. Let's see. Now, by the way, do you agree that me spending time on pushing you to spot your mistakes in your code and then recovering from them is instructive?
Yeah. No, it's good.
Okay, very good. Because I don't want to waste your time if you would rather just get the final answer and
This is more
Yeah,
fun.
okay.
This is more fun.
Okay, very good. Okay, so let's get into my filter. Right. Now, here's my filter. First of all, I call the function P because it's a predicate, right? And I do have two overloads, one for empty lists and one for non-empty lists, right? Now, then I check two things. I check whether, and this is new syntax to you. So you had seen is invocable underline V, but you had not seen is invocable underline R underline V. No, we are in C++ very much proud of our torching of people with our bizarre names, right? So this one says that it has to be invocable with that return type. So the return statement of, the return expression of calling P on X should be convertible to bool, right? And given that this is not the pack itself, right, I have a separate, requires subclause here for the single X and another for the pack, which then expands when you perform the pack expansion. Okay, and remember that these need to be separate, because if you don't make that separate, the pack expansion rules say that, okay, I am going to go into the ... the ellipsis here, and take a look into the operator, and then try to, index through the operand, the other operand, according to the pack expansion. Which, if we had included what's on line 230 as well, it would have wanted to perform indexation on X as well, in addition to X's. And it would have said, I don't know how to do that. Right? Now, so that's about the required. Now, then, so what we do is that this is the way that I did it. I said, okay, we anyway would want to perform the filtration on the tail, So let's do that once. We acquire the tail of L, and we call filtration on that, right? And then if the head satisfies the predicate, then we prepend X to rest. Otherwise, we just return the rest. Now, here is a question for Niels. Why did I want to perform an if const expr here, and instead of performing a ternary like there is on line 235?
Is it because you can't do a const expr ternary operation?
That's also true, but suppose that we did have a const expr ternary.
Then I don't know.
Okay, thank you. Mikhail, do you know?
Well, I guess the normal ternary is not compile time. Or
That's what Niels also suggested at the first trial.
Yeah.
So suppose that we did have, and we don't, but suppose that we did have a const expr ternary. Yawn, did you? Sorry, Jan, did you yawn?
No, I opened my mouth.
Okay.
Oh, well, then I don't know.
Okay. Jan, do you have any idea?
Thinking. I guess you can check the invocability on the tail. You checked that before with the const expr, but that's, I guess, what the other one said as well.
Yes.
Which means, I
Well,
mean,
okay. It looks like you don't know the answer. That's fine. Here's the answer. You see, we are returning two statements here. Sorry, two expressions. The one is rest, and the other one is prepend of X to rest. Right? What are the types of these two? And here's the hint. Are they of the same types?
No.
They are not of the same type.
Because one of them has an extra element.
Absolutely. Now, the thing about the ternary operation is that it wants the two operands, so it takes a condition, and then an if operand, sorry, a then operand, and then an else operand, right? The ternary wants the two branches to reduce to the same type. But that's not possible here, because we know that they will be always. It's not that sometimes they would have, and the compiler just figured out that it can't. Sorry, the compiler just said, I can't figure out those few occasions where they would be the same. We are absolutely sure that the two types are not the same, because one of them will always have one extra X at the beginning than the other one, which means that they will always have different types. That's the reason why we can't do the the ternary here, right? Now, we have already spoken about the address implementation. Now, I would like to invite you to give this some good readouts on your own. You know, it's good fun, but I'm not going to delve into that for the moment. Especially, you know, the ideology of dependent pairs is something that it's a very acquired taste. You have to really read it through. But I think, Jan, specifically for you, who is doing like Agda,
yeah,
this might be, you know, something you want to take.
I'm aware of dependent pairs. I use them a lot. I use them
Okay.
all over masters.
Right. Right. Okay. So you already know what this is all about.
Well, yeah, I didn't know that the double star was the way Idris expressed them, but
right. It's not well documented, to be honest with you.
But yeah, for the other two, if you guys have done any logic.
Done what?
Have you done any logic?
No, I haven't taken any logic course, no.
No, but if you've done exfil,
yeah,
in MNF, I think you guys discussed what it means to be existentially quantified.
It's a few years ago.
Yeah, let's say there exists something that fulfills a property. You can formalize that as existential quantifier X implies PX.
Okay.
Existential quantifier X dot PX, more like, yeah. And the dependent pair is the way you can express that on a type level, at least according to the Curry-Howard isomorphism.
Well, it's more than that, because you are not, that's not an existential proof. That's a constructive proof. So the way you do it in dependent pairs is that you construct the proof and you hand it over to the compiler.
Yeah, the proof is the second argument of the pair.
Or any of them. I mean, it's in what you pass around. You know?
But at least in MLTT, we tend to require it specifically to be the second one.
But I don't know what MLTT is.
Martin-Löf type theory.
Oh, I see.
Yeah.
Okay, well, right. It's sure.
Dependent function, usually.
Okay.
But if you have it, then it doesn't matter. Yeah, you can have it either way. Because it's like
the implementation. Yes, the implementation can be.
The way I always think about it is you have the thing, and then you have the proof of the thing. Right. So you have there exists a thing, and then the proof that that thing exists or fulfills the property is the second term. But you could also think, okay, the thing is the first term, second term is the proof.
Right. I mean, yes, makes sense. Yeah. And one more thing, you could have so the proof doesn't need to be model theoretic. Sorry, that doesn't need to be proof theoretic in general. It can be, so you can have. That's why I think in a lot of the Martin-Löf implementations of the theory, you have a model theoretic approach which says that I have evidence for this being available.
Yeah, you can think of it that way. Yeah.
Right, which is still existential, but the way that Idris has implemented that is constructive, which means that you have the proof readily, and it can, point to the ways that you can construct the element that you get.
Yeah. I mean, that's the way you do it in Agda too, though.
Right. Okay.
Most of the time, you have it as a using that internal identity type, which is like, I guess, of giving evidence. But yeah, people should probably get going. You have vacations to do, so.
No, they have job, and we should stop the recording.